So variables and expressions, we're going to get into order of operation. You've all heard of order of operation before, right?
Yeah.
Remember a little acronym? Yeah. We'll do that in a second. So as we're doing these, what I'd like you all to do is try to do them without a calculator, okay? Because what I need is like some automatic arithmetic happening in your brain so we can get on to height, right? You can check it with a calculator, it's fine, but I want you to get used to not using a calculator as much as possible, okay? So what is an expression? Can anybody tell me what a mathematical expression is? Or can anybody read? Yes.
Expression is any combination of numbers that we know and ones that we know.
Numbers that we don't know, we generally call what? Variables, right? X, Y, Z, N, B, whatever. And then Greek letters like, theta and epsilon, but you'll get the calculus, whatever. So I would say that actual definition is a little lacking, right? It's not any combination, because an expression is generally this combination without any equal sign. If I have two expressions connected with an equal sign, what would you call that? I'll give you a hint. The concept of equal sign is in the name of what we call it. Yes, equation, right? So know the difference between an expression and equation. Equation has an equal sign. Expressions do not have an equal sign. You with me? I do want to give you a quick note to review order of operations. So we'll do the notes page. Let's go to our blank notes page here. There we go. Order of operations. What was that little mnemonic acronym you said? Okay. DOS. So let's look at what each one of those stand for. What about the P?
Parentheses.
Okay, so anything that's inside of parentheses or grouping symbols, and there's more grouping symbols in math than just parentheses. There's brackets and there's the horizontal fraction bar and whatnot, right? So anything inside of there will get done first, and then the E stands for what? Exponents, like squaring and cubing, right? Like 5 squared is 5 times 5, yeah? Right? 25, okay? What does the M stand for? M is multiplication. Now, I want to add something to this here. There's a lot of times I find kids haven't heard this before, but when you have an expression and there's a bunch of multiplication to do, you work from left to right. Have you heard that? No. Okay, so we have to add that. That's important sometimes, right? Left to right. So I'll just put L to R, okay? And then division, right? Again, you have to do any division sequences from left to right. Okay, that's the convention. So kind of group multiplication and division, right? Because it's like these together, it doesn't, like if you do multiplication first and then division, it doesn't matter if you switch that and do division and then multiply, okay? So I kind of like to group multiplication and division. And then, of course, the A stands for what? Addition. Okay, and then finally the S. And again, I like to group these, right, because adding and subtracting can usually happen in any order, as long as it's just those things, okay? Now, this is important. Up here, we're talking about parentheses, and I mentioned grouping symbols in general. You guys know that horizontal bar for a fraction that makes a fraction? That is very important to know. That is also a grouping symbol, like parentheses, okay? So this is important. A horizontal fraction bar is a grouping symbol. Okay? It acts just like parentheses. Just like as an example, if I have like 5 plus 4 divided by 2 minus 8, if I'm thinking order of operations, and you do things in parentheses first, right? Because this also means the horizontal fraction bar also means division, right? Which is our D, yeah, right? So this is like the equivalent of this. And what work would you do first? To stuff in the parentheses before you divide, right? Okay? So a horizontal fraction bar, yes, it is division. It's the operation division, but it is also a grouping symbol if there's more than, one term on either top or bottom. Everybody got that? So they get and a lot of times when kids put stuff in their calculator and they see that fraction bar, they just hit divide and they get the answer completely wrong because they didn't put parentheses around the top and or the bottom in their calculator. Okay? So we'll run into that and you guys should be able to get it. All right, we got this here? Okay. Again, if you get behind trying to copy these down, they'll be on Teams a little later. Okay? All right, so let's go down here and review our order of operations. This is pretty simple, should go quick, right? Give me the value of each one of these. Now, as you guys see me write things, I present my math in a very neat and orderly form, right? I like to think of algebra as a language. Anybody here take a foreign language? Or English?
Oh, yeah.
So languages are designed to convey specific things in a certain way, right? And certain words mean certain things, and certain punctuation is required, right? So I want you guys to start thinking, because I'll be real picky about this. I treat your algebraic presentation as grammar, right? And I get real picky about like not having equal signs all the way down and whatnot, okay? That makes, you'll see. It'll make sense. But anyway, let's take a look at this first one. 3 times 2 plus 7. Which operation we do first?
4 times 2.
Okay, so this would equal what? 6, right? Plus 7, which then we do the, right, PEMDAS, 13. Okay? So I connected them with equal signs because they are all equal to each other, aren't they?
Yeah.
Without the equal sign, it really has no meaning. It means one of them is not related in any way to the other, but they are. They're all equal, okay? There's a typo in this second one here. This should be right in here, and it's 1/2 times 6. It should be squeezed in there. That's a typo, okay? All right, so PEMDAS, what should we do first?
Can you do multiple?
Say it again? Okay. Or we could think 1 times 6 divided by 2, or we could say half of 6, couldn't we?
Yeah.
So we're going to leave the 8 there for a minute. Let's do this multiplication here. Minus, what's 6 divided by 2? 3. Okay. Plus,
24 divided by 6.
okay, why don't we do, because we can kind of do multiplication and division together, like I said, right?
Yeah.
What's 24 divided by 6? 4. All right, now what do I do? Addition and subtraction from what? Left to right, okay? So 8 minus 3 is what? Plus 4 which is 9. Now, I'm putting like almost every excruciating little step in here just to be on point with order of operation, right? I know you guys are just probably in your head doing 8 minus 3 plus 4 is 9, right? But I want to emphasize the left to right thing. Okay, let's look at this next one. I'll go down below it because there's not much room over there. So we have parentheses, we have grouping symbols, right? Okay, so we should do that stuff first. So this would be 4 times what? 2 minus 7 times 2 again, right? Okay. Now we have some multiplication and some subtraction. Let's do multiplication first. Gives us what? 8, 14, which is what? 8 minus 14. Negative 6. Okay. Okay, let's look at this next one here. Hey, we have that horizontal fraction line there. That is also considered what? That's like what? Like parentheses, right? So for our PEMDAS, P, parentheses, we got to think of that. I'll put them in here just to remind you, right? So up there and down here. Okay. Well, now, the top set of parentheses, within that top set, there's some exponents that we have to deal with first, right? We have 5 squared. What is 5 squared? 5 squared means 5 times 5.
25.
25 minus what? 4 squared. 16 plus 3 over what? What's 1 minus 5? Negative 4. And again, you're not required to put the parentheses there. I'm doing it to emphasize the point, okay? All right. So now let's take care of this addition and subtraction from left to right in the top. 25 minus 16 plus 3. What's 25 minus 16? 9 plus 3 all over negative 4, which then becomes what? 12 divided by negative 4. And what is 12? This division now finally divided by negative 4. Negative 3. Okay? Let's move on to E. We have some parentheses and we have some exponents. Okay? Now I know that, okay, so I don't want to confuse you here, right? But there's PEMDAS, P, parentheses, then exponents, right? But you notice the exponents are kind of separate. Could we kind of do them at the same time without altering anything? Yeah, we could, right? So let's do the parentheses work here first. 2 minus 7, negative 5 times 2 plus, and I might as well, right, see what I mean? I can just, why don't I just do that now instead of putting another line in there? Right? 9. So now I have to do what operation? Okay, and what do we get? Negative 10 plus 9. What is negative 10 plus 9? Negative 1. All right? Let's look at F. There's more than one thing up there. I want to emphasize grouping. Again, I don't need you to put them in there. I want you to see it. So what should we do first on the top? What operations are there? We have multiplication. We have what? We have division and adding. So the multiplication division we're going to do left to right, don't we? Okay? So let's do that. Equals, what's negative 16 divided by 2? Negative 8 plus, might as well do 5 times 2, yeah? 10. 2 to the third power. What is 2 to the third power? Use your fingers if you need to. 2 times 2 is what?
4.
Times 2 is 8. Right? Okay? Now let's do work in parentheses again. Wait, I don't see any parentheses. What am I talking about? Yes, the fraction and its grouping. So what's negative 8 plus 10? Well, okay, which is it? Positive 2, right? Over 8. Can I reduce 2 over 8 to maybe the lowest terms?
1/4.
Yeah, divide top and bottom by 2, right? That's 1/4. Okay? That's kind of on the simple side there, right? But you learned a little something extra about order of operations, right? You learned the fraction bars, grouping symbol, and multiplication division get done left to right. Okay? All right. Let's go down to exercise 2. Now they just want us to kind of describe what's going on here in words. So they got X's in these expressions. So we got letter X. Explain the calculation for each of the following. So in part A, 3x minus 8. So for doing stuff to X here, what's the first thing that gets done to X? X is what?
You need to isolate it.
No, we're not solving. We're just describing, like, if you were to plug something in for X, what would you do first? Like, what operations? It gets multiplied by 3, doesn't it? X is multiplied by 3, and then what? After that, what do we do to that result? And 8 is subtracted. Okay, that's what I'm getting at. So X is multiplied by 3, then 8 is subtracted. Okay? How about in part B? What's happening to the X first and then next and whatnot? 4 is subtracted from X, right? 4 is subtracted from X. I'm going to abbreviate. Then, what?
Divided by 2.
The result is divided by 2. Then, the result is divided by 2. Huh? How about in C? What's happening first, second, third, fourth to X? What are we doing to it? Well, not 4X, just the X. What's getting done to the X first? Think of order of operation. PEM. What's happening first to the X? Okay, PEM.
It's being multiplied by 4. By that.
Is getting squared for exponents, right? Exponents come before multiplication, don't they? Right? So the first thing we do to the X is what? Square it. That's called, right? Multiplying, squaring it, right? And then what do we do to it? Then you multiply, right? Exponents first, right? Okay. So first X is squared.
Multiplied by 4.
Then multiplied by 4.
Then subtracted 8 is subtracted.
What's that? Then 8 is subtracted, right? Then 8 is subtracted. Okay? I'm glad we did that one. It's straight on this stuff, okay? You guys notice that the 4 doesn't get squared here with it, right? Even though it's like touching the X, right? The only way that I think I think the way you said it, it would have had to have been written like this. See how the squaring applies to then both of them, right? Does that make sense? You guys understand that distinction I just wrote up there? Right? Okay. That 4 doesn't get squared unless it's in parentheses and being squared, okay? All right. What's on the next page here? Evaluating expressions. Evaluating means you get some numerical value, right? See what it is equivalent to. That means finding the results of calculations of an expression when all variables are values are known. So really, this is just plugging in. You guys did that. You find something's equal to something else, you can replace it, substitute, or plugging in. So this is plugging in. That's all. Okay? So exercise 3. Please given expression, explain the steps. Explain in steps what the calculation is doing, and then find the value. All right, they say a lot of stuff. So they want us to evaluate 4x minus 7 when x equals 5. Well, x equals 5. You see this x here? What can I replace it with? Because it's equal to it, right? Yeah, you can't. You don't have to. That's what I could. You're right. You could either write it like this, right, or like that. Either way, right? And in some cases, in certain situations, it will matter. Okay, but that's fine. I'll do it in parentheses. There's multiple ways to show multiplication in math. Some are more appropriate than others. So 4 times 5 minus 7 will equal what? Minus 7. 4 times that.
9.
Oh my, 4 times 5 is 20.
20 minus 7, which is 13. Okay. Here we go. Let's look at the next one, part B. Didn't we? Okay. My thing about explaining, and I know the Common Core loves to make you guys write entire essay explanations in that. That bothers me a little bit. I get it, and you'll have to do it from time to time. But didn't I tell you algebra is a language? And how would you have explained it? Using the English language?
Yeah.
It seems redundant when we just explained it mathematically. Does that make sense? I don't like all the excessive writing all that much.
Maybe it's for blind.
Until we get to geometry and do proofs, so there's a lot of writing, but that's different, okay? Yeah, algebra's a language. Look, I just explained it. How much more clear could it be, right?
Maybe it's for something in
Blind?
Yeah.
Well, then we need Braille or something. Okay, well, if it's blind, they can't read what you wrote anyway.
Yeah.
Okay. 8 minus 2x squared. When x equals negative 3. Got to be careful with this one here. And so 8 minus 2. Now I definitely want to use parentheses here, okay? Instead of the other way, this is one of those situations where now it's more appropriate instead of just a dot, right? Negative 3 gets squared. Okay? So what should I do first? The 8 minus 2?
No. Negative 3 squared.
You got to do the squaring, right?
3 times negative 2.
Or
No, negative 3 squared, and then
Now let's be careful. 8 minus 2 times, what's negative 3 squared? Say again? Is it? You sure?
I don't know. 3 times 3.
What is okay. What is negative 3 times negative 3?
Oh.
Yeah, that's 9.
Positive 9. So guys, whenever you square something, you always get a positive result. Got me?
Yeah.
Whenever you square something. So this is going to be 9 here. So now we do 8 minus 2, right? False. What do we do now?
2, negative 2 times
8 minus 18, which gives us what? Negative 10. Okay? Let me just, a quick distinction here. You can write this down or not. Hang on. That, let's say I had, I'll just make a good page here. Negative 3 squared, we just said was positive 9, right? What about this? What does that equal?
Same thing.
Think about the one with the 4 we talked about earlier. Is that also positive 9?
Yeah.
No, it's not
No,
negative
it's
9.
not that square.
The negative's not getting squared, is it?
No.
Wait, think of it this way. In front of every number, you can think of it being multiplied by what? 1, right? Isn't that really this? Isn't that really that? And so that -1, or just that negative sign, does not get squared. Everybody with me?
Yeah.
So it's 3 squared, and then you multiply by negative, you get -9. PEMDAS. Exponents and multiplication.
Oh,
Exponent, then multiply.
I can't remember now.
Go ahead.
Well, what'd you say?
Okay? Let me get rid of that page. So this is an important distinction, right? Whatever's in the parentheses gets squared, right, with everything else. Okay? If it's not around parentheses, just the thing that the squaring is hooked to gets squared. For lack of a better way to phrase it. Okay. Back here, where were we? All right, let's try part C. Got this thing when x equals 2. So now we have like 2 grouping symbols, don't we? We got parentheses and a fraction bar, okay? So that would be 2 times -2 plus 8 all over 3. I'm not going to put the parentheses in there like I do, right? What the heck, I will. Why not? I'll do it like this. So they're nested parentheses, aren't they? Okay. All right, what do we do first?
The -2 plus 8.
And what's that? 6, right? Over 3. Now what do we do?
Multiply it.
Okay, so give us 12 over 3, which is 4. Now, do you remember when I put PEMDAS up there? I kind of grouped multiplication and division together. So when you get to that point between the two, let me ask you this. Let's do division first. Let's say we do, what's 6 divided by 3?
2.
2 times 2.
4.
Hey. So you see when you get to just multiplication and division, the order most of the time doesn't matter. Okay? All right. Let's have you guys try for a second. I'm going to give you a minute here on your own. Okay? Take this expression, and even though it's multiple choice, I want you to show the work like we did. Okay? Plug it in and evaluate that and tell me what you got. All right, -3. So the first thing I had to do was the exponent squaring. 4 squared, 4 times 4, 16. Right? And then -2 times 4 is 8, -3. Okay? Half of 16 is 8. -8 minus 3. 8 minus 8 is 0. Right? And -3. Okay? All right, any questions on a lot of this is reviewed. Do we have any questions? Okay. So you have a problem set right over there on the next page. Okay? They'll both be due tomorrow. I know it's 2 of them. But again, this will all be over in January. Okay?
How long was that?
How much? I don't know.
Like,